Today the ds-incubator continues with the series about testing our code, and today we're going to be covering snapshot tests along with CJ and Monica. I'm going to be doing a little introduction to the idea of snapshot tests, what it is, and how to actually implement it with test that. And then Monica is going to be talking a little bit about our experience using snapshot tests with images, with plot images, and then CJ is going to be sharing his experience with one approach that makes working with images in snapshot tests a bit more robust and less brittle. But that will make sense in a moment. So to begin with, what is a snapshot test? Usually, and if you were in the previous meetups, you saw that one of the main functions that we use from the test.dat package to test our expectations is to compare the output of a function with some code that you write actually there on the test that should match the output of the code. So basically, in a normal test, what you do is you compare with code the output that you expect with some output that you write there on the test. But sometimes it is not convenient to do that. I'm going to mention three times when that's not convenient. And when that's not convenient, sometimes it is convenient to store the expected output not in code, but in a file, in a separate file. And that is all that there is to snapshot tests. So once again, and that's the text that is highlighted here on my screen, snapshot tests is the idea of saving the output that you expect, not in code on the test file, but instead on a separate file. So it's not, in front of your eyeballs. And test.dat has implemented the idea of snapshot testing in different ways through the different versions, but lately it has improved quite a lot. So the three times that it is convenient to use snapshot tests are, for example, one, when the output is a string of text that is kind of awkward, and that to reproduce that in code, you would have to escape a lot of characters. For example, you have to escape end of line characters. That's one case. The other case is when the output that you expect is very large, like for example, ggplot2, for example, returns an object that can be plotted to the screen, but is an object on itself. So you could query its structure, and you will see that it's a very complex object that has a lot of elements. So if you wanted to write that output in code, it would be very long, very difficult to look at, very difficult to read and to understand. So instead, you can probably save that output on a snapshot outside the test file and into a separate file. And third, when the format is binary, when you're working, for example, with images or plots that produce images, and you want to store, for example, a PNG file, and that's what Monica is going to be talking about today. And then CJ is going to be talking about an alternative to storing data in pixels as opposed, which is PNG. And he's going to be talking about another approach that is kind of more robust. So that's kind of the theory of snapshot testing. It's just storing the output in a separate file. And what I'm going to be showing is very briefly one motivating example of snapshot tests to see how it actually works on test.dat. So here I have this. Here on the screen, what I have is a small RMD file, as you can see here, an R Markdown file. So if I knit this file, what I get is a little bit of text, blah, 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 and then the session information. So that is a common use case where you want to share along with, along with your document, you want to share information about your session. But that is kind of awkward because the output of session information is very long, and the kind of it really varies the the text of my document. My document, is blah, 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 and it's just one line, and the output of session information is super long. So I would like to kind of hide that a little bit. So I'm going to show you how I could do it. I could use a little bit of HTML and use this tag to wrap around the chunk of code that outputs session information. And now my R Markdown file will output this nice kind of drop-down menu that hides the details, right? So I can expand or contract it. And now my document is a lot more readable. So, okay, this is the use case that I would like to say, okay, I like this idea. I want to create a little function that does that for me. So how would I go about that? What would that function look like, and how would I test it? And that is the point of showing you today. So let's call that little function SI for session information. And this is it. This is the code. It is the details are not super important here. What I want to show you is what happens when I print SI to the console. As you can see, my implementation of this little function is, I run the little function, and immediately on the console I get some text that I can copy, right? And I could paste. Sorry, I can copy. Ooh. And then I can paste it in any. Say that I have this, right? So I can just paste it. I copy it from here. I paste it in a new file, and I already have that drop-down menu for the session information, right? So let's pretend that that's a very useful function, and I want to keep it in my personal package. And I added also a little test as a reminder. A little message as a reminder that this code is not automatically copied to the clipboard. Instead, I had to copy it manually from the console. So let's test this function. If I wanted to test this function, the output is quite complex. Is something that it's very difficult. It has multiple lines, and also if I try to put that into a vector, when I print X, it's null. Actually, the output is concatenated to the screen, but it cannot be stored anywhere, right? So it's very difficult to test in the traditional way with a function like expect equal. So instead, all you do is you call the function expect snapshot. And it takes the function that you want to test, or the expression that you want to test. In this case is SI. That's all that there is. And now I just run my tests. I'm going to run them with Ctrl-Shift-T. That gives me this pop-up menu that I can confirm to save the file. That will run my test, and here underneath you will see that my test passed. And you will also see that, well, actually, because I did run this test before, but the first time that you run expect snapshot, it will save a file that looks exactly like what I printed here on the console. And if you run it interactively, you get the output that will be stored in the file. So the file, where is that file? Well, that file is saved here under the folder tests. Here, tests. Test that, right? And snaps. There you can see that SIMD, actually the HTML, I think I did it, that's a mistake from me. So that's the output that was saved by test that. And the beauty of it is that, as being an MD file, I could look at this file on a pull request directly without having to run the code, or on GitHub directly. You can go to that file on GitHub, and that's what it looks like. So you already see the output that function produces to the console, but instead you see it on a file. Right, so that's the magic of snapshot testing. And also notice that the little message that is printed also appears here as precisely marked as a message. So expect snapshot captures the output printed to the console, also captures messages, and also captures errors. So let me show you before I pass the baton to Monica. So if I wanted to show an error, for example, I could do, this function does not take an argument, it has no arguments. So if I did pass an argument, this should fail. So I can capture that in my snapshot test saying error equals true. I can tell snapshot testing that I would like to see on that file that is stored as output, I would like to see what error message I get. So now that I run the tests again, you can see that I get a little warning here. It's telling me that the output has been saved, right? And if I run it again, I don't get anything at all, right? If I changed and the last thing I'm going to show, if I change the implementation, say that I remove the message, the output of the function is going to be different, and therefore the snapshot test will tell me that something has changed, and I will get an error. An error that is quite informative because immediately I can see in what way the file has changed. And I can see that before the output had this message here, and now the message is no longer there. So if I want to say, okay, that was an intentional change, all you need to do is to follow the instructions here. You just run this code here because the test will continue to fail. If I keep running tests, the test will continue to fail. So if you want to update your snapshot to say, hey, I know that this is failing because it's an intentional change, all you need to do is to just run the function snapshot accept with the name of the file that contains that snapshot. So by running that, you update the snapshot, and now if you run your tests again, then the test will pass because it will have acknowledged that your change is intentional. Okay, so that's the gist of what snapshot testing is. It's kind of a little bit intermediate, I would say, not maybe advanced, but intermediate skill. So maybe if there's more questions, we can discuss that later or cover it in more depth in a kind of testing in the wild in another meetup. But for now, I would like you to hear a little bit from Monica. Go ahead, Monica.
Can I share my screen? Because
yes,
I thought to
thanks.
the code also.
I stopped my screen now. Let's see if we can see your screen. Yes.
Right. So we use snapshot testing together with Mauro in the plotting package that we are developing now, but more for data sets. And then we thought that maybe it would be also cool to test the output visuals. So basically, like really see if how the plot looked like in the past. Does it still look the same? And one of the ways to do it is using this expect snapshot file. So basically what you do is instead of having this snapshot in this snapshot format, you actually save a PNG file, and then during the test, a new PNG file is created with like your current function implementation, and it's compared to the one that you have stored as a snapshot. And it seemed like a perfect idea, because then we could check if the output changed, and you also get like a user interface where you can actually see what changed. Like it will show you the differences between the snapshot and your current version. However, in practice, it didn't really work for us, or we decided not to implement it because actually this save to PNG is very, how do you say? It's sensitive to the machine that you do it on. So basically, Mauro created this PNG snapshot, and then I ran the test on my machine, and then I got differences which were just related to the fact that it was created using a Linux and I have a Mac, and somehow the PNG was rendered slightly differently. So I guess it's useful sometimes, but it wasn't useful in our case because of this fact that it would basically give errors all the time. And also, since most of the time when we are developing this package, I am actually changing something in the code, so the output will be different. So then also I would have the errors all the time just because I changed the output. So yeah, in the end we didn't use it, and I think CJ has some better idea for this kind of testing that he's going to present to us.
Yeah, I'm not sure if it's better, but it addresses some of those issues. And I don't have any thing prepared to show you, which might have been a mistake, but I tried to explain this. So yeah, just as Monica explained, when you test the images for a PNG, the snapshot testing is testing a binary comparison, so it's exact one-to-one replication of that image. And what happens is when you generate the PNG in R and save it to a file, there's a lot of things that can make things just slightly different. And sometimes it's so small that you can't even see it, like a human can't even see the difference. So it could be just one pixel is different, and that will change the thing. And this can happen because, for instance, a lot of the things are outside of the domain or the normal domain of R. So it can be operating system versions. It can be the version of the font you have. There's a lot of, it can be whether or not you have anti-aliasing or what degree of anti-aliasing the thing is doing to create the PNG. So there's lots of very minute differences that can be caused by many, many differences between operating systems, font system, anti-aliasing system, the PNG exporting system. So yeah, you end up with this situation, which Monica and Barb experienced. So one alternative to that I've used before is by testing the SVG output of a plotting object, which is convenient because really any object in R that's ready to be plotted, primarily a base R plot or a ggplot plot, when you tell it to save as a PNG, what it's doing is taking a vector representation of that graphic and converting it into a PNG. If you instead convert that object into an SVG, it has a more, let's call it a more stable output because it's not affected by the fonts. So I don't know if you ever looked at an SVG, but it's kind of like HTML, which probably all of you know a little bit about. Each little part is separated by specify what it should be. So it may say, give me a red triangle that's 70 whatever pixels tall and 80 pixels whatever, and then it can say, write this text, this is my title in a certain font with a certain color, but it doesn't actually render that font. So the advantage of this is it's a little bit less sensitive to those really minute changes, which means that you can test that for the most part the image is the same, but you're not testing the actual precise implementation of your specific machine. And that means that you can test it more broadly. So a lot of people that are using Snapshot tests on PNGs, they end up testing this just locally on their own machine, but it never gets added to continuous integration. It's not something that someone else would run on their machine. If they're hacking on it as well, it's maybe only the maintainer of a package or something that's like this would run it. But if you're doing the SVG thing, it's probably practical to have this in CI testing or having another developer use it because it's not as sensitive to those minute changes between the machines. The other advantage is when you see the change, it's not just two images next to each other or even a more fancy slider where you can see the difference, but it's actually in text. So an SVG is a description of a vector graphic in text. So when there is a difference, when it does notice the difference, it will tell you just like in a normal GitHub diff or merge conflict or something. It will show you precisely the lines that change and precisely the values that change, which can make it a lot easier to determine what went wrong. Because if you see that the font is now set to gray instead of black, that's really obvious where to go to fix that. But if you look at the output and you're like, I don't know, the font looks maybe the font's a little bit lighter, but I'm not really sure, then it might be much more difficult to figure out why that is the case, because maybe it's anti-aliasing, maybe it's color. So yeah, I think that's a good enough explanation, but I know it's a bit confusing. It took me a long time to figure out what the difference was, so happy to answer questions about that as well.
Thanks a lot, both of you. I may be able to show a little bit of, like snapshotting the object underlying ggplots, but best to probably check first what questions and comments there are, or experiences or frustrations in this group. Go ahead. Yes, that was.
I should also say really quickly, there's a package called vDiffr, VDIFFR, I think, that manages this SVG style testing, and it's integrated with testthat and blah, blah, blah. So it's a lot easier. You could hypothetically do this yourself, like instead of exporting a PNG, export an SVG, but the vDiffr package makes it a lot easier.
Cool. Any other comments or questions over there?
I have a question about the snapshotting testing, specifically the type that you were showing, Mauro. So it's not super clear to me. That's taking a snapshot of just whatever is returned to the console, or is it, like if I had a function that created a file, like created a directory, dropped some files in it, then like sent me a warning, and then also then returned an object. And the function could do a lot of things, so it wasn't clear because of the way it was written. It kind of gives the impression that everything that function does, it captures, which I guess is hypothetically possible if it was using like with R or something like that to have this completely contained environment. But then it's kind of seemed like it was only looking at the console.
Yeah, Alex, I see a hands up. Would you like to respond to CJ, or do you have a question for the queue?
I think related to CJ's thing is it wouldn't necessarily be able to operate on a whole directory, but if you wanted to have whatever you're doing, like throw stuff into a directory and then zip it up, it could do a literal comparison on the zips.
That's a good point. Yeah, basically, as far as I understand, I'm relatively new to the implementation in testthat 3, but I have been using previous versions of testthat with something similar. As far as I understand it, snapshot testing in testthat 3, the expect snapshot interface is like a broad interface that captures everything, standard output, which is whatever it brings to the console, errors, messages, and warnings. Errors with the caveat, you have to explicitly say that you expect an error with error equals true. So whatever your function, if you figure out a way for your function to look into that directory and output something like a list of files in that directory, a list of paths, then I guess that you could use snapshot testing in that way, because it could be output to the console, right? And then the idea that Alex mentioned is also a good one, because there's other flavors of expect snapshot. Like for example, expect snapshot file is one case, and it has different. There is an argument that you can say what kind of serialization you want, and it could attempt to capture anything from a JSON file to an RDA file, depending on basically how much readability you expect or how much reproducibility you expect. On the JSON side of the spectrum, the file is very readable because you can just look at the text. But then there has to be a conversion between the actual object and that JSON representation. And then on the other side of the serialization spectrum, you have these fully binary files that are stored as whatever object it is, and that's probably the suggestion that kind of not exactly that, I think, but close to the suggestion that Alex made. And then you won't be able to kind of read it, but if there is a difference, it will tell you, well, there is a difference here. Then it's kind of up to you to figure it out. Alex, go ahead.
Yeah, I just want to put in one more use case for this kind of testing, and that is, this can be useful if you don't know how to test your stuff yet, but you have I have some inputs, and then there is this giant monolithic function that spits out something at the end, and there's a whole lot of stuff that happens in between that I haven't tested yet, but I want to make sure that at all points the overall process still works. You just test to make sure that the thing that it spits out at the end is still the same.
I totally agree, and that's the use case that I use the most, especially when you're doing refactoring. And also I wanted to correct myself when I said expect snapshot file with serialization options. I was wrong. It is expect snapshot value, I think, from the top of my head. So yeah, I think let's see if I was thinking of running one session of testing in the wild, and I was thinking of showing precisely the use case that Alex is mentioning, because it's the most prominent in our code, where we start with something that is already implemented and we want to refactor it. So the very first, it's easy to implement just one test that captures just about everything, and then kind of go from there. And if something, if you change something that changes the observable behavior of that function, that test should kind of capture it. So that's how I use it a lot. But that would probably spark a bunch of questions. So I wanted to dedicate maybe a full meetup to that. Maybe with Alex we could work together on that one. That'd be great. Do we have any other questions or comments or follow up from what we discussed so far?
Yeah, I was just going to say, you mentioned already the expect snapshot file, which that's what I originally tried to use doing this SVG testing until I started using the vDiffer. I'm like, okay, this is easier. I don't have to do this myself. But the expect snapshot, if it captures like the entire environment of that thing running, that's actually pretty cool for some of the reasons that's already been said. I had this impression that it only captured some kind of like the console output or something, but if it captures the entire environment, it's actually pretty useful.
I don't think it captures the environment itself unless you save it somehow as a, if you capture the environment and you save it as an environment, maybe you could store it, but it's output, messages, warnings, and errors as far as I know. But we could explore that a bit more. Actually, in my experience, capturing the environment was brittle. I did it. Maybe I'm going to show in the use case that I was mentioning. You can capture. If you do str and a ggplot2 object, you get the list, right, of the underlying ggplot2 object, and one of the elements of that list is plot_env, which is run specific. Every time that the plot is generated, it creates a new environment where the plot is kind of created. So to make a snapshot test that was useful of a ggplot2, I had to nullify that one element. So I got rid of the kind of random environment that is created every time that the test runs. Everything else I could use in the snapshot, but that one thing I had to assign null to kind of kill it, right? But I'm hoping to show that in a full meetup probably later, so if it wasn't clear. So for now, I think we ran out of time. I'm sure that a lot of people was like, what is this? But those who have been using tests, I hope that will find this useful, or someone that hasn't yet in the future maybe reviewing this meetup. Thanks everyone for joining. See you next time.